In this episode, I'm joined by a returning guest to talk about artificial intelligence, augmented and virtual reality, as well as hiring. Hi, and welcome to ScaleYourCode.com. My name is Christoph Limpler, and I'm back for another episode after a short little break. Now, I actually moved out of state, so things were a little bit crazy there for a period of time, but I'm starting to find a new normal, so things are getting back into schedule. Now, in this episode, I'm really excited to welcome back Eric Elliott to the show. If you remember, roughly about a year ago, I think it was last June, I don't remember the exact date, but sometime in June, I had Eric Elliott for the first episode where we talked about JavaScript best practices, Node.js, and ending poverty with code. So I'm going to introduce Eric right after introducing my two sponsors, Rollbar and DigitalOcean. Now, Rollbar was actually one of my very first sponsors of the show, and they're back for more because this was a very popular offering. If you go to scaleyourcode.com/rollbar, ROLLBAR, you'll get their Bootstrap plan free for 90 days, which is an $87 value. Now, since Rollbar gives you error tracking for all of your apps in any language and on any platform, including JavaScript, of course, this is a deal that you'd be crazy not to check out. I personally use Rollbar and I highly recommend it. I also personally use DigitalOcean for certain projects, and they're also offering free stuff for a free month of a 1 gigabyte droplet, which you can use for all of your JavaScript projects. So go to scaleyourcode.com/DigitalOcean to get that sweet deal. Now, like I said, if you've been listening to the show, last year I had Eric Elliott on the show. So Eric, welcome back, and how have you been?
I've been great. Thanks for having me back. I'm really excited.
Yeah, thanks for coming back. So since it has been a year, what have you been up to? What have you been doing?
Oh, man, I've been just putting out more JavaScript courses, playing with new technologies. I got really deep into React and Redux and been having a lot of fun with those. And yeah, that's about it. Just working.
So actually, what do you think about all those different changes and different tools that have come out? Have they introduced anything that we haven't had before? Or?
So Redux introduces a more functional approach to JavaScript state management, which is pretty amazing. I've really enjoyed building it into my projects, and it's really simplified things like unit testing for your app state management, and I really appreciate the simplicity of reducers in Redux. So, and if you're not familiar with Redux, the reducers are just regular reducer functions for the purposes of app state management. And when I say reducer functions, I mean the functions that you pass into things like the array.prototype.reduce that actually do the accumulation of a single value from a list of potentially many values. So using reducers for state management has been really amazing and totally transformed the way I think about building apps. So I've been really happy with it.
So there have been some really useful transformations then from the past. From what you're saying, sounds like it anyway.
Yeah, yeah, definitely. I've also played with Angular 2 just a little bit, and I've been playing with TypeScript. TypeScript and Angular 2, I've got mixed feelings about both of those so far. Angular 2 compared to React and Redux, it feels like it's just got a lot more overhead and not a lot of benefit. In fact, like writing unit tests for the views in Angular 2 is much more complicated than writing unit tests for things like pure components in React. So I'm not really feeling it yet, but maybe as I use it more, I'll start to feel it a little bit more. TypeScript, I really like the IDE type hinting that it gives you, and I like the type inference capability so you don't have to manually annotate everything, which is fantastic. It's a really amazing feature. And I like that better than the type annotations available with Turn.js. But the problem is that since it needs to see how the types flow through the program, sometimes it will infer types that are a little bit too strict, and you have to go and manually loosen up the type annotations. And sometimes it's really hard to do that, especially if you use any kind of really complicated functional programming techniques, which I tend to do once in a while. Um, then you start to wish for features like higher kinded types and things like that. I don't want to go too deep into that, but um, I'm feeling like the weaknesses of TypeScript. And I recently wrote an article called, what was it called? The, uh, what was it called? The one about TypeScript. Oh man, I can't remember the name
I
of
think I
my
remember seeing it,
article.
but sorry, I can't help you there. I don't remember.
Well, essentially, it was about how people, not just people, but me included, expected that static types would give you really strong protections against bugs.
Yeah.
And it turns out I've looked at several studies on the topic since then, and it turns out that it doesn't really reduce overall bug density in production, like the bugs that escape into production, very much at all. There's a little bit of an effect, but it's a really weak
Hmm.
effect. It's much smaller effect than I would have expected from it. Um, Especially when you compare it to things like test-driven development, TDD, where you write tests for the functionality of the software before you implement the software. And when you get TDD and you get good test coverage, um, your the number of bugs that escape into production is reduced between 40 and 80%, and the number for static typing is like closer to around 3% reduction. So it just isn't a very strong effect compared to lots of other things. So when I feel like my productivity is both boosted a little bit because of the cognitive load relaxation, like I don't have to remember all the interfaces because I can just start typing the function call and it tells me the interface for it. That's really, really wonderful. But when I have to go and manually re-annotate the types because the inference is wrong, sometimes especially when it gets into like a difficult thing like any kind of polymorphism or any kind of like higher kinded typing situation, that stuff just slows me down, so it gets in my way almost as much as it helps. So I'm kind of on the fence. Like I really like type annotations and interface annotations for documentation purposes and to help the developer understand how to use an interface. But when it comes right down to like, should this thing be throwing errors at me and preventing me from doing my work? I'm kind of blah at the moment.
Hmm.
Not really. The interesting thing though is that Haskell has a really great type system, and I've never felt like that one got in my way. So just depends on what the type system is and how it works and stuff. But yeah, there have been some interesting developments in the last year.
That's really interesting. I would have thought for sure that it would have reduced errors like you thought. So I'm glad they did some research on that to prove that it actually doesn't. Because I mean, logically speaking, you would think that would be the case, especially when you work with it. But I guess not. So that is really interesting and definitely a topic that we could spend a lot of time on. But when I was thinking about last year, June of last year, and all the differences between then and this year, and what happened, I couldn't help but feel like we should talk about some of the big advances in artificial intelligence as well as augmented and virtual reality and things like that, especially since you have written blog posts about it. On Medium, I know that you post a lot of things on Medium. I'm not exactly sure if you actually have a personal blog or if you use that as your personal platform or not, but
Medium is it, yeah.
yeah, I mean I use it for that as well. It's very powerful. But one of the posts that you posted is called "How to Build a Neuron: Exploring AI in JavaScript," and you have part one as well as part two. So first of all, before we even dive into what that blog post is, I gotta ask you, man, how do you come up with all these different ideas for all of these blog posts? Do you have like a secret pipeline that you could share with us that really helps to bring out that creativity, or how does that work?
So one of the ways that it works is that I just get a ton of questions from people who are learning about JavaScript and learning about new technologies, and sometimes those influence what I write about. And then sometimes I'm just working on something and I come up with an insight and I think I should share this with everybody, with the greater world, because there's some learning here that's worth sharing. So it's a little bit of a mixture, and of course, I write for my students. So there's certain areas that I'm just covering because it needs to fill in some knowledge gaps that a lot of students should be learning but aren't. So that's kind of how that happens. Specifically with the AI post, I don't remember how that popped into my head, but I think I might have just been I think I might have just been thinking about all the applications of, for instance, augmented reality and how much AI is needed to really pull that off and make it work well. Um, so I think that's probably what it was, is that I wanted to fill in some knowledge gaps about like how these technologies work. You could just go and download a library that does some pattern recognition for you, and then you could skip trying to build it yourself. But I want to get people thinking about like how does the human brain work, and how can we mimic real intelligence using machines? And a lot of the current algorithms don't really do that very well. They do it to a very limited extent. So they have to be very, very specifically coded and specifically trained for a very particular task. So, for instance, like if you want to do image recognition, you use some neural network and you train it on like how to recognize cats, or how to recognize like people's faces, and things like the Instagram filters work by recognizing your facial features and figuring out where your eyes are, so they can put on like funky shades and stuff like that. That's all using artificial intelligence. So I was just thinking, a lot of people are going to apply this to a lot of different apps and a lot of different things, like self-driving cars is a really big push right now. There's going to be like 500,000 self-driving cars on the road within the next 4 years, or at least added to fleets like Uber. So Uber's planning on buying 500,000 just by themselves, and then there's other companies obviously producing self-driving car fleets. So that stuff is just going to be really big in the near future, the next 20 years or so. It's going to play a huge role in our lives. So I just want to get people thinking about, how does all this stuff work? How does the human brain work? How can we make computers think as well as people think, and in certain ways? They already think better than we do on things like how to add numbers together, and things like that. So what we need to get computers better at is the general ability to learn anything. And that's kind of what I was getting at with that post series.
So actually, you start that post by saying, years ago, I was working on a project that needed to be adaptive. Essentially, the software needed to learn and get better at a frequently repeated task over time. So this is exactly what you're talking about. But is this actually possible to have code that learns from its environments and from things that it's already done and that it does repeatedly? How does that work? How is that possible?
Sure, absolutely. Well, of course, it's possible because we see it every day. Anytime like Google, or Google Photos or Facebook automatically tags a photo for you, it's because that software has learned to recognize people's features and recognize specific people, so it knows how to tag them when it sees them again. Um, so you see this all around you. Augmented reality is completely dependent on this because it has to be good at pattern recognition so that it can detect edges, it can detect surfaces, it can detect walls and floors, so it can position things correctly in your field of view, in your real reality. So, I mean, this stuff is clearly possible because people are doing it, right? Um, and the specific software I was writing, it was trying to figure out what data is most likely to be needed for the next request for a specific person. So it could do pattern detection based on what is the previous state of the app, what is usually the next state of the app, when it has that previous state. And so it can learn to predict the user's next needs in terms of which data needs to be sent next. And in that way, it can pre-queue that data and have it ready to send and it can reduce the amount of data that needs to be cached in memory and so on. So yeah, and that was 2000. So that was like a long time ago that I was able to do like very, very limited, very, very simple pattern recognition back then that didn't require like huge, huge resources. But now it's like just much, much more impressive. They've got augmented reality apps that let you carry around your cell phone and like point it at things, and it'll speak out loud like what you're looking at. And they're using that for things to help aid blind people in understanding what's around them in their environment and things like that. So yeah, definitely is possible, and it's used quite a lot actually.
Thank you, Rollbar, for making an incredible product that has helped me more times than I can remember. And thank you for sponsoring the show. Error tracking is extremely important, but it's a pain to keep up with. Or at least that's what I used to tell myself. Then I found Rollbar, and now it's a breeze. Rollbar offers full stack error tracking for all apps in any language, and it does all of that for a very affordable rate. In fact, they're offering Scale Your Code fans 90 days free for their Bootstrap plan, which is an $87 value. Go to scaleyourcode.com/rollbar, ROLLBAR, to check it out and to plug it in your application in 5 minutes. Then, if a user runs into an error, you'll know as soon as it happens. Go to scaleyourcode.com/rollbar and try it out. You actually included a video that I found very interesting, or it was a series of videos where I'm sorry, I can't remember who did it. I'll put a link below it if I can remember, but he had matrices where you had the number of hours spent studying and the result on the test that you got, and then you had like maybe 5 or 6 of those entries, and then you had to figure out, well, if I put in this many hours studying, what is going to be my grade? And you can do that using basic Python functions to try to decide that pattern recognition, and that's exactly what you're talking about. And that's
Yep.
what you were doing in 2000, but like you said, nowadays, I don't even know what kinds of things are possible with that. I'm not sure a lot of people do, which is why I really want to try to shed some light on that, because to me, since it's not something I'm very familiar with, it kind of seems like magic, right? It's like when you start programming, you think, oh man, how do they do this? It's like magic, but it's not. If you actually try to figure out the logic behind it, you can get much further with it. So that is something that I'm trying to shed some light on for myself and for other people as well.
Yeah, it's interesting to understand that it doesn't actually manipulate the code. It's not like reprogramming itself. Instead, what you've got is a network of neurons. So just like your brain has a bunch of cells that are all interconnected, it's just this great big network in your brain with hundreds of trillions of connections in your brain. You can't do that on computers yet, but we're getting there. We will soon. But you're not going to emulate that on your MacBook anytime soon. But yeah, it's just this network of interconnected things. And neurons are really, really simple. All they do is take inputs from a bunch of other neurons, around 100 other neurons probably in some situations, much, much fewer in a lot of neural networks. There's a lot of simple neural networks that are nowhere near the complexity of the human brain that work with much fewer connections. And they do their simple pattern recognition tasks okay. But the human brain can have, potentially hundreds or thousands of connections between neurons, which is really, really a complex network. And what happens is that each of those inputs gets weighted based on whether or not the input neuron and the neuron that's weighing the inputs, whether or not they fire together frequently. And what happens is the neuron listens to all of the connections to it, and when a lot of other neurons, a lot of other inputs are firing at the same time, then that neuron fires too. So as soon as like the number of inputs reaches a certain threshold, it fires what's called an action potential, and then that gets delivered along the axon to a bunch of other neurons. So the axon is the output, and dendrites are the inputs. So it listens to all the dendrites, and when there's enough signal, it fires a signal down its axons to other neurons' dendrites. So that's basically what a neuron is and how it works. And the way that neural networks learn is they weight those inputs. So, for instance, if two neurons tend to agree a lot, then that neuron's input has a lot more weight. So the weight gets increased over time. If they tend to disagree a lot, the weight gets decreased over time. So when this neuron is firing, this other neuron doesn't believe it. It's like, I don't need to fire with when this one's going, right? So it might actually create like an attenuating effect on the input. So instead of amplifying the sum of the signal, it subtracts from it. So that's kind of how the basic idea of how neurons work. And the way that a lot of neural net algorithms work is they take the result that you're after, and when the neuron output doesn't match that result, it creates like an algorithm to calculate the difference and try to weight the inputs accordingly. So and there's lots of different algorithms that are used to try to do that training. So one of them is like a regression algorithm. And then there's a bunch of other algorithms for neural networks that are also really interesting. Like some of them, instead of trying to weight the inputs, they just rewire the network completely. And those ones are usually based on genetic programming. So there's an algorithm called NEAT that uses genetic programming, and there's another one called HyperNeat that tries to balance the structure of the network a little bit more than the NEAT algorithm works, and and so on. And then there's a bunch of other statistical models, and so I could go on and on about all the different ways that people have tried to emulate human intelligence in machines. So like hidden Markov models is a really popular solution that's been used a lot in like audio recognition. So it can listen to your speaking and interpret that into sentences and text and try to parse what you're saying. And I think they've also used that a lot in like optical character recognition. So handwriting scanning stuff and things like that.
Three questions based off of everything you just said here. The first, actually, there are plenty more I'm sure I could find, but let's narrow it down to three questions. The first one, how do you know all of this about neurons? How did you learn this?
So when that first AI thing that I started working on, decade and a half ago, I guess, I that really sparked my interest in it when I realized how powerful it could be and how I could use it in so many different applications, and how I could harness that in different ways to do different impressive things that I thought were impossible with computers. That really sparked my interest in it, and like I wanted to understand how the human brain works, and so I got into neuroscience studies a little bit, and that kind of got me interested in trying to emulate how real neurons work on computers. But it's only been recently that we've had the computational power to really start emulating the complexity of how real neurons work in a meaningful way. Up until now, we've had to rely on like the math techniques and use a bunch of training inputs and do a bunch of statistical modeling and regressions, and it was nowhere near real time. So we have not had a really good solution for real time machine learning up until very recently. And now our computers are much, much better. And now I'm starting to think, well, maybe we can model neurons a little more closely. And so that post was not, that series was not about like how to model it with math and statistics, as much as like how can we simulate the functionality of real neurons and what can that get us? And I don't know the answer to that yet because I don't think it's been done really well. There's a couple of programs out there that do it a little bit, but a lot of them are focused on like the deep science, learning how the brain works. So it's trying to recreate the networks of the real brain and kind of map that out visually and help scientists understand how it all fits together, but they're not trying to use it for real practical applications of machine learning. At least not that I'm aware of. And if you know different, please like comment on this podcast, and I will look through your answers later because I'm all ears. I want to learn as much as about that as possible. Um, yeah.
The second question, I was debating whether I should actually ask it or not because it's a bit of a weird question, but is it actually does it make sense to try and emulate what neurons actually do, considering that they're organic material versus computers are non-organic, they're machines, right? So can we actually ever get close enough that it makes any sense to try to even do it?
So there's a whole body of scientific research, and I kind of have to like put scientific in bunny ears here because um, it's so outrageous, it's so like outlandish and sci-fi sounding that if you try to like say science, it sounds like you're a pseudoscience quack, right? But there's a whole body of research that is about um, really simulating the human brain's functionality down to the molecular level. So what they're doing is they're taking little tiny like microscope scans of little tiny sliver cross sections of real brains from things like mice and stuff like that, and they're doing these scans, and they're also doing these for human brains, but not using live specimens. Obviously, they're not killing humans and like slicing up their brain and
Hopefully.
scanning it.
Hopefully.
They're not doing that yet. Watch out. um, but yeah, this is a whole body of research where they're trying to actually emulate real brains. There's an interesting project that's emulating the entire physiology of a real worm, including all of its neurons. So this worm, I think, has neurons like all over the place, not like a centralized brain, but what they're doing, and that one has 302 neurons total. So super simple to emulate, you would think, right? But it's still, because it's emulating every molecule of that organism, it's really doing a lot of computation to do that emulation. So that's, I can't remember the name of that project, but it's the C. elegans worm. And if you Google worm emulator or something like that, you'll probably find it. And then there's uh, in Europe, there's a project that's trying to emulate the human brain, and then there's another project trying to emulate the human brain in the United States. So there's like three major research projects that are trying to emulate the brain at the molecular level, and some people are seeing this research, this body of research, and this path of research as a way to achieve immortality, because if you can increase the scanning technology enough to do a molecular level scan of the entire human brain without killing somebody, right? Then you can record like all of their memories and all of their thought patterns, their thinking patterns, which are actually hardwired into the brain, because that's how the brain works. Is it adapts its network over time, adapts the physical network. So if you can encode all the physical characteristics of the brain and you can emulate a human brain on a computer, then that computer is thinking in every bit as much realism as you thinking, right? So it can think just like you can think. And that, I think, a lot of people see as a potential for really achieving immortality. So there's it sounds all crazy and quacky and
Yeah.
pseudosciency and science fiction, right? But this technology is really being developed. But I want to emphasize, like, we're nowhere near that.
Right.
We're taking the first little tiny baby steps into it, and uh, it is still science fiction currently. What is science fact is that we can emulate small networks with hundreds of neurons. But the idea of emulating the entire human brain with all of its 100 trillion connections, it's nowhere near being satisfied. But I must say this. Um, 7 years into the Human Genome Project, the mapping on computers of the Human Genome Project, we were something like 2% into it. 7 years later, it was finished. So you have to take the exponential increase of our technological capabilities into account when you think maybe we are 0.2% of the way into emulating the human brain, but maybe in 20 years it'll be done. So, I mean, just because it's taken us a long time to get where we are doesn't mean it's going to take all that much longer. It's not a linear process, it's an exponential process.
Sure.
So
And
it is like it seems like when we're thinking
yeah.
about it right now, it seems like it's really far away vision. Maybe in 100 years we'll be there. Well, if you're modeling linearly, sure, it'll take 100 years, but that's not how technology works. So
That's true, but at the same time, you have to think about all the legal implications of it, where you have certain parties that will freak out if this is even possible. So, who knows if they can pass bills to make sure that it's even a reality or something that can be actually practically used. So,
honestly, like when it comes to legislation, anytime legislation has attempted to block the mark of technology, it's the legislation that got killed, not the technology. So, and that's universally true. They tried to block the automobile. Look how that worked out, right?
yeah,
They tried to block the internet. Look how that worked out, right? They tried to block music sharing, and the music industry almost died, right? So, trying to legislate the existence of a technology away doesn't work.
they'll probably slow it down a little
They
bit,
could slow
but
it down.
not completely stop it.
They
Right.
could slow it down like and if you're looking at the timeline of history, they can slow it down for like a year or two, maybe, but it's a tiny blip and it'll get back on track, right? So,
Interesting, super interesting. And I know they're also looking at creating these meshes that can go inside the brain and can like fit with your organic material. And I don't know how far along they are with that. I haven't really done that much research for it, but that's also
yeah,
very
that's
interesting.
that's true. They're getting a little bit into one of the interesting things about the human brain and how neurons work is they don't care where their inputs come from. So, for instance, if you were blind, they could put a patch on your back. They actually have done this. They could put a patch on your back that'll take input from a camera and like map that input to like electrical stimulation on your back or like physical stimulation on your back, and your brain will start to detect the patterns and you'll see through your back, right?
Wow.
So like the neuroplasticity of the brain is truly, truly remarkable. So when they're talking about putting a patch in your brain, what they're doing is like doing little electrical stimulations on the neurons, and it doesn't matter where they put that, the brain will start to sense patterns from that and start to be conscious and aware of what those patterns are, and it'll become like another sense for you. There are people who are blind or colorblind, and they've one guy mounted a camera to his head, right, because he couldn't see colors, and he patched it into his like basically the part of the brain that connects your ears and wires up the audio inputs, right? So he hears colors. So it's
What?
pretty crazy stuff.
How
Pretty.
do you hear colors?
Yeah, that's a super good question. And if anybody really understood exactly how all that works, I think that would be a really major advancement in our understanding of the brain. But yeah, it works. It works. I don't know how, but it works.
So
Um,
all of this begs the question: what role does JavaScript actually play in all of this that we just talked about?
so the interesting thing about JavaScript is that it's ubiquitous. Ubiquitous. It exists on just about every device. So it's interesting, like if you want to enhance the capabilities of any given device, the most obvious way to do it is to write some code in JavaScript. Now, that said, it's actually really, really hard to emulate real neurons in JavaScript, and that is because JavaScript is not very good at timing. And real neuroplasticity is timing dependent. So there's like a 20 millisecond window between when one neuron fires and another neuron fires. If they fire within 20 milliseconds of each other, then there's going to be some neuroplasticity response. If it's within 20 milliseconds after, then the network is strengthened. And if the previous neuron fires later than the other neuron, then the neuroplasticity is weakened. So basically, if there's boom boom, right? One neuron fires, the other neuron fires in response, strengthened connection. If it's the other way around, this neuron fires, but this neuron was asleep at the wheel at the time that that happened, it disconnects them more. So cells that fire together wire together, and cells that fire apart wire apart. And in the human brain, in real brains, animal brains, this is timing dependent. So you have to know, like, did this happen within 20 milliseconds, and like what was happening with the signals inside that neuron. And in order to emulate that, in order to simulate that in JavaScript, you either have to build a fake clock that gives you like 20 milliseconds of leeway, because JavaScript's timing is so choppy and so unreliable, or you have to kind of break out of JavaScript and use other APIs that are built in like C++ and stuff like that. And we just happen to have one of those APIs built into the web platform. It's called the Web Audio API, and that fires 44,000 times per second. So it's much, much more accurate than the timing of like set timeout and stuff like that. So there actually are ways to do it in JavaScript, but I wouldn't say that JavaScript is the ideal language to do it in. I choose JavaScript for this kind of thing because JavaScript is the language that I use the most, and it's the one I'm most familiar with. And if I'm going to learn something, I would rather use JavaScript to do it, so I'm not learning two different things at once.
I mentioned a discount from DigitalOcean at the beginning of this episode, and I'd like to share why I thought this sponsorship could really benefit you. DigitalOcean is not only one of the easiest cloud platforms to get started with, but it's affordable and it's built for scale. Don't just take my word for it. Look at the platforms using DigitalOcean. You've got Docker, Red Hat, Akamai, Zendesk, and a ton of others. In fact, it's the fastest growing cloud infrastructure provider. DigitalOcean lets you customize your own infrastructure or choose from pre-configured one-click images like Node.js, Docker, and a bunch of others to quickly get you started on your project. Go to scaleyourcode.com/DigitalOcean and type in promo code ScaleYourCode, which is all one word, and you will get 1 month free on a 1 gigabyte droplet. An entire month. Do you know how much you can learn or even build with that much time? Go to scaleyourcode.com/DigitalOcean and type in promo code ScaleYourCode. And then come tell me what you built. I'd love to see it. We just took a little bit of a trip into the future just now, but let's come back to today and what's actually available to us today with augmented reality and what we can actually do there. A perfect example of this, of course, that's extremely popular right now, Pokemon Go. Everybody's going crazy over it, and it's opening floodgates to other possibilities. And I'm sure there are a lot of people trying to find ways to monetize that right now. So what role does JavaScript play in that?
So building an app like Pokemon Go is much, much easier than it sounds. Like, the basic functionality of Pokemon Go is really, really simple. They don't actually do a lot of environment detection with the placement of the Pokemon. Like, you'll notice that sometimes it seems like a Pokemon is just hovering in midair. It's not sitting on any particular surface. So I would say that the current state of Pokemon would be super easy to emulate in JavaScript. Really, it's the location APIs that are the most complicated parts, and figuring out how to distribute things like the Pokestops and the gyms and stuff like that is a much, much harder problem than actually displaying the mixed reality in that Pokemon Go uses. So their augmented reality is really just like it's overlaying a very simple image on top of a background, a video background, and that's really easy to do in JavaScript. Um, Now, I think that those kinds of apps are actually going to be really popular over the next few years, especially after the explosion of Pokemon Go. It really, when some new technology comes along, what tends to happen is that the technology is there for a long time and it's ready for a long time. Like Ingress is basically Pokemon Go. It's the same damn game essentially, right? But it's using like different IP, different intellectual property, and but you can actually use Ingress to play Pokemon Go. You run them side by side, like all the Pokestops are the same as the portals and Ingress and stuff like that. Um, and they're like literally the same game pretty much. Um, but it takes it takes a killer app, one that's wildly popular, to really explode people's eyes, like break them out of their traditional mode of thinking and make them realize there's something to this.
Mhm.
There's really something to this. So now that Pokemon Go is making $10 million a day, everybody and their dog is going to be making augmented reality apps for the cell phone. And I was starting to worry because the augmented reality technology has been around for so long. Like it's literally been possible to make a game like Pokemon Go for about 10 years. And it took that long for somebody to do it, right? Um, but now that people see the potential of it, I think you're going to see a ton of games trying to be Pokemon Go, the next Pokemon Go. And I think what a lot of people don't realize is what made Pokemon Go successful wasn't the technology, it was the IP and the immense popularity of the Pokemon brand. That's what made it successful more than this is an app where you walk around and catch little creatures, right? If without the Pokemon Go, without the Pokemon name, Pokemon Go is nothing. It's like a blip on the radar. It's another Ingress, right? And not to discount Ingress. It was a good game and it was a really cool demo of the technology. But yeah, it's actually not that difficult, and JavaScript is perfectly fine for doing something like that. And
So how can you actually get started with doing something like that? If, say, somebody's listening to this and they still want to try to create their own version of it, do you know of any tools or frameworks or anything like that that are more geared towards creating AR games, or is it just
I think if you want to play with AR, don't play with the fake Pokemon Go AR. That's not the real AR. I mean, it's cool that Pokemon Go is so popular and so wild, but if you think that Pokemon Go is augmented reality, you don't know augmented reality. The real AR is very exciting. It's going to completely transform our lives, and in a decade or so, we're going to wonder how we ever got along without it, just like we wonder how we ever got along without our cell phones. Like, I remember a time before cell phones, and like, I didn't realize what a difference it could make until I actually had a cell phone. And then I was like, I'm taking this for granted. This is like a part of me now. I don't want to go anywhere without my cell phone, right? Um, but like when cell phones were brand new, we used to make fun of them, right? We would make fun of the people walking around with these bricks on their faces and be like, "Who do they think they are?" Right? But now everybody's got one, and it's a wonderful thing. Like something like 2 billion people have cell phones. That's a big chunk of the world population, and the only people that really don't have cell phones are people living in the third world where they don't have anything. They don't have running water, they don't have electricity, and they've got no way to get an internet connection in the first place. So I think that augmented reality 20 years from now is going to be as ubiquitous as cell phones and as every bit as transformational, potentially a lot more transformational than cell phones. So it's going to basically you're going to be wearing the internet on your face 24 hours a day. So
there's so many different things that are about to change, or at least it feels that way. I mean, I know I'm living in it now, but there have been all these different revolutions throughout the history. But this one feels very real to me now, especially with all these changes. So it's very exciting, and I'm sure we could keep talking about this all day. I do want to ask you before we wrap up a few questions about hiring, since I know that you do have a lot of posts about this as well, and you talk about it quite often, especially for JavaScript candidates. But the thing that I've been realizing, especially recently, is hiring is not just hard, or finding a job and hiring is not just hard for the candidates themselves, but especially for the companies trying to find talent. So I've got questions for you for both sides of the coin. And let's start with candidates where maybe they just graduated from high school or college and they don't have those years of experience that a lot of companies are asking for. How can
Yeah.
they find jobs?
Build stuff. Build stuff. Actually, we've got, I don't know if the audience is aware, but I have courses online at ericelliottjs.com. And we have some brand new projects, student projects. They're just basically app ideas for students looking for stuff to build. They're assignments that a student can clone the project on GitHub and build an implementation of that app, and they have it on their GitHub, and then they have some code to share with potential employers, and they can show that, yes, I understand what closures are, I understand what objects are, I understand how to structure an application, and that can help them get their foot in the door. Build stuff. The thing that really got me my first really good programming job was an open source project that I built. It was a form validator library, and that was really what got me my first job, is just having that good example of some good code online that is useful for real people. And I think that people who are complaining, like, how do you get experience when nobody will hire you if you don't have experience? Well, build something for yourself, turn it into something good, like write good code that's well structured, make it open source, share it with potential employers, and say, see, I have proof that I can code. You're not just a guy with some keywords on a resume anymore. You're a guy who's got real projects that they can look at. And that's how you get your foot in the door. Yeah.
And I would even go and say that it doesn't necessarily have to be a big project or something that doesn't exist already. You don't have to reinvent things. You can just build something that you find fun and interesting. Even if there's another
Sure.
version of it out there, that doesn't matter. You're still getting that experience. You're building it differently. I mean, as long as you're not copying and pasting things, then.
Yeah,
But if
sure.
you're actually building it from the ground up, I think that's a tremendous learning experience and also great for your resume, as you were saying.
Sure, literally. If you can avoid copying and pasting from other project examples, you could even just put your own little spin on a to-do app, and that's good enough. As long as like it does something that shows off your creativity and your abilities in a way that like isn't totally just like cut and paste from somebody else's project, right? So
What if somebody's switching from a different industry and they've been in the workforce for a while and all of a sudden they realize that they really don't like this industry, or that, I don't know, they're trying something different? How is it the same thing? Should they work on different projects even if they don't have a lot of time to do that and they've got bills to pay? What advice would you have for that?
um, do it in your off hours. Do it at night on weekends. Just do it. You know, you don't really have any other alternative, right? Either you have the experience to get hired on a development team, or you don't, and you're not qualified. So, development teams aren't hiring people, even for junior roles. They're not hiring people who have never touched a line of code before. They're hiring people who have coded, who have built something that they can look at, and you can't just say, I read a JavaScript book and expect to go out and get a job. You actually have to get some practice under your belt, and jump online on things like Free Code Camp. Come to ericelliottjs.com and do some practice projects and get those under your belt, and then start looking for jobs. And initially, your first programming role is going to be a junior role, even if you write something on your own, unless you turn that something into a successful business and you can say, like, during this 2-3 year period on my resume, I made a successful business off of the software that I built, and then that counts as experience, right? But if you just like got a couple of student projects on your GitHub, that's not experience, and you're going to go into a junior role,
Sure.
right?
What about using recruiters? Does it make sense?
Don't. Honestly, I think that recruiters are a plague on the industry. And I'm not trying to hurt any recruiter's feelings. I'm sure you're a wonderful person, Mr. Recruiter out there in the world, just trying to make a living. I understand. I understand. But recruiters do more harm than good, in my opinion, because all the senior developers like me are basically it's basically kind of a form of like a legal harassment, legal stalking. Only instead of one stalker, I've got 1,000 of them. It's just not cool. It's just not a cool way to, you're creating problems for people instead of solutions for people. If you really want to create solutions, transform your role. Instead of being a recruiter, learn about the technology that the company is hiring for and turn yourself into a technology evangelist and let the candidates come to you instead of the other way around. There are plenty of candidates looking for jobs. There's hundreds of thousands of developers out there who potentially might want to make a career change. Let them come to you. Do something really, really cool and put some content out there and let the candidates find you instead of hounding them, because it really creates a big problem for the industry. And most recruiters, they don't bother learning about the technology. They get some keywords and they do some searches and then they throw stuff at the wall until something sticks. They don't understand how to screen candidates, so they send candidates who are not good for the roles to the companies that are looking to hire, and that wastes that company's time, a tremendous amount of that company's time. Whereas like somebody like an agent who has partnered with real techies and pre-screened their candidates and been very selective about who they take on, they can send really, really high quality people. And I happen to know a really good agent, so JS Cheerleader on Twitter, follow her. Um, but yeah, recruiters just are not good for the industry, I think. Instead of doing that, you can shop around. Like there are pipelines producing new talent. So the company really has to right now. Okay, I got to backtrack. Take a couple of steps back. There's a huge problem in the industry. Like there are right now, the only way for junior developers to get a foot in the door is to go to general purpose coding agencies that get hired to build cheap apps, cheap first versions of apps, or cheap marketing landing pages for companies that just want to do some marketing for their products. And they're really crappy developers. Their teams are really lousy developers. They're all newbies. They're all pretty green, and they're all building substandard stuff, with few exceptions. There are some good agencies out there, but in general, how a lot of developers get their foot in the door is they go to agencies who tend to hire a lot more junior developers than big tech companies, and that is really problematic, because the companies who are building the real apps, the real production apps, not just the first version one prototype, those companies tend to exclusively concentrate on hiring senior level developers. And the problem with that is that there just aren't enough senior level developers to fill all the roles that are opening up for them. So, and that shortfall is only widening. And by 2020, we may have a million unfilled developer roles out there because people are looking for people with much more experience than what the job pool currently has. So it's really hard to find good senior level developers in the market. One thing that a company can do to change that situation is, for every 2 to 3 senior developers you hire a junior developer and then have that junior apprentice with the senior level developers. Pair them up and have the seniors mentor the junior developer. And if you do TDD, if you do code review, and if you do a lot of pair programming for your junior developers, then what you'll end up seeing is that junior developer is very quickly going to come up near the level of the senior developers within a year or two. And and while they're doing that, they're also providing fresh insights. The great thing about junior developers is that nobody has ever told them that something is impossible before. So they're willing to try anything. And they bring fresh approaches and fresh insights that your senior developers are not going to think of, because the senior developers have built this track in their mind of like how things are done, and you just do it that way,
Hmm.
right? That's how we ended up with MVC for 2.5, 3 decades, right? And then React comes along and blows the doors open, and there's a fresh approach. That's what junior developers can do for your team. They can blow the doors open off your traditional way of doing things and help you see fresh approaches that the senior developers aren't going to see. So it's really important to have junior developers on your team, not just because they're easier to find and hire, but because they also bring fresh insights to the team, and more diversity on your team is a really good thing.
As the company trying to find that talent, whether it's senior level or even junior level, how do you screen candidates?
Very differently, depending on whether or not they're senior or junior level developers. So a junior developer, which you're not necessarily looking for what they know. You're looking for an eagerness to learn and evidence that they have learned a lot in a very short time. So junior developer coming on, ask them like, what have you been doing to learn? Do you have some projects on GitHub that I can look at? What, like, have you been on Free Code Camp? Have you, been on Eric Elliott JS? And like, if you've been looking at like all the Egghead tutorials, like, how is it that you are getting your information? And what is it that makes you excited about learning? And why do you want to learn how to do this stuff? And why do you want to get into the industry? You ask them questions like that, gauge their excitement level and the amount that they're learning and look at how much they've learned and in what time frame they learned it. If they have, if they've been developing for 7 years and they're still at the junior developer level, um, maybe turn that candidate away. Maybe that's not the one to hire. If they've been developing for 6 months and they're already building like an impressive little app in React and Redux, and they're already learning about functional programming, and they already know about like object composition and modularity, and if they already have some sense of all these concepts within 6 months, hire that person right now. Don't let them walk out the door, right? Because that's the kind of person you want, somebody who's really eager to learn and is a constant learning mode, because that's what development is today. It's not just applying what you knew yesterday to every new problem. It's learning what you don't know yet that can make the app even better tomorrow.
I think this is a really good note to close on. Eric, thank you so much for doing this episode again, coming back on the show to talk about some really interesting things. I'm going to have to go back through this episode and listen back to everything we talked about, but it was definitely very interesting and learned a lot. So thanks again for doing that. If people want to follow up with you, or if they have any questions, or if they want to check out some of your work, how can they do that?
They can go to ericelliottjs.com, check out my courses. That's definitely like the key. I think I'll teach you a lot of stuff that you don't know yet about JavaScript. I guarantee it. Um, and I think that regardless of how many years you've been programming, I can teach you something new about programming that you didn't know yesterday. So definitely do that. You can reach out if you want to contact me. Really, the best way to get my attention is through JS Cheerleader, because I'm always busy, and she can help me find the people that need my attention the most. So
She's great.
JS
Definitely do that.
JS_cheerleader on Twitter. She's always very helpful. She's definitely a great resource. So yeah, do that, and buy my book, Programming JavaScript Applications. And I've got a new one coming soon,
Oh,
so
nice.
watch for that.
Yeah,
Yep.
is it still a work in progress? Can you tell us anything about
It's
it?
a
Or
work in progress. It's super top secret right now, but it's coming. So
awesome, keep me posted. And if you want to contact me or get in touch with me, you can follow me at Scale Your Code, or you can contact me at chris@scaleyourcode.com. Thank you everyone for tuning in. Don't forget to leave a comment to thank Eric for his time. See you later.
all right, thanks.